Hello, today we are considering the structure of an atom and studying isotopes. And today we will find out how an atom can change its charge depending on how many particles, protons, neutrons, electrons there will be in an atom. How the structure of an atom will change if some of these particles are in different quantities. So, to begin with, let's recall. Let's say we have the element oxygen. Oxygen has an ordinal number 8 and a mass of 16. If we talk about this element and call it the number of protons 8, it coincides with the atomic number. The number of neutrons, it has 8. It is 16 minus 8, and it will have electrons 8 according to the atomic number. Then in this case it is easy to notice that the number of protons and electrons, that is particles that have opposite charges, in this atom will be the same. So such a particle, oxygen, will have 0 charge. That is, this particle has no charge. Since there are an equal number of protons and electrons, let's say, and if we have oxygen with number 8, mass 16, and it will have 8 protons, it will have 8 neutrons, and let's say electrons will become 10. How is this possible? For example, if oxygen will take 2 electrons in the chemical process, but then note that it does not have the same number of protons and electrons among themselves, which means that this particle will have a charge. Which charge? The charge in this case is negative, and this charge will be 2 minus. Such a particle will be called an anion. In addition, oxygen can pass into another particle. For example, its number will be 8, its mass will be 16, and it will have 8 protons, 8 neutrons, but electrons will become 6. How can this happen if oxygen interacts with the most electronegative element, that is the strongest metal? This is fluorine, and then oxygen will give its 2 electrons to fluorine, and then the number of protons it has is 8, electrons are 6, that is 2 less, which means that such a particle will have a charge of 2 plus respectively and will be called a cation. Thus, it turns out that the atoms of the elements can change their charge. Let's go back again. If the number of protons and electrons is the same, then the charge of the particle will be 0. This is an electroneutral atom. If a particle has more electrons than protons, then the particle receives a negative charge. And at the same time, it will be exactly the same as exactly how much is the excess of the number of particles of electrons compared to protons. And if the number of particles, protons and electrons is less, then the charge will be so correspondingly greater. How much will be the difference between protons and electrons? Now let's try to do a training exercise of this kind. So here are the encrypted chemical elements whose symbols we need to identify. For each of these particles, the number of protons, neutrons and electrons is given. Based on this, we will determine which element is taken. So first, let us determine that for element D, we have the number of protons, 27. So its serial number, atomic number, is equal to 27. To determine its mass, we add up the number of protons and neutrons. That would be 57. Now what this element will be, this element is the element cobalt. Now we're going to establish what the charge of this particle is going to be. Since we have a number of protons 27 and electrons 25, it turns out that we have protons more than electrons by 2. So this cobalt will have a charge of 2 plus, and it will be an ion. We move on to the second element. In this case, its number is 43. Its mass would be 97. what element it is. It will be a technetium element. Now we need to establish what the charge of this particle will be. Let's see. Protons 43 and electrons 42, that is one less. So technetium will have a charge plus, and it will also be a cation. The next element labeled Ku, so 35, so the ordinal number is 35 atomic number. So if we add up 35 and 44, there will be 79. Because the 35th number has bromine, we established that this is the element bromine. Now we need to establish what the charge will be. For this, we will see how many protons and electrons there are, and their number is equal. So bromine will have a charge of 0, and it will be an atom of bromine. The next particle is 27. So the number 27 mass 32, so that makes it 59. But since the number 27 is the element cobalt, we write down that it's cobalt. Now let's see, and it respectively has 26 electrons, but 27 will be protons. So again, there are more proton particles, so cobalt will have a plus charge. The last element is the 35th element, so number 35, the mass will be accordingly, we have 81. Now this is the element bromine. Now we again compare protons and electrons and see that one electron becomes more, and therefore bromine will receive a minus charge and will become an anion. So the particles of an atom can have different numbers of protons and electrons between them, and in this connection it is important to see what the charge will be. This has to be determined correctly. Now if we were asked in this case to determine what kind of particles we have got, we would say particles with charge are ions, but if we say what atoms are depicted here, here is depicted, for example, bromine in the form of an atom, and it is only one among the elements proposed here. Now a little bit more information about what isotopes are. Now a little more information about what our isotopes are. You know, isotopes are substances that can react in chemical processes. For example, there's a reaction between nitrogen gas and hydrogen, which leads to the formation of ammonia. Ammonia is a gas. If you equate, you get this chemical equation. It's the very famous chemical reaction of GABA fusion. What would change if we took an isotope of hydrogen instead of hydrogen? Then nitrogen would react with that hydrogen, for example, deuterium, which would have a similar compound. It would be Nd3, so it would be a derivative of nitrogen and deuterium. The coefficients would be the same. As we can see, our chemical reactions are very similar. Then the isotopes are said to have the same chemical properties. But nevertheless, the isotopes are different, because if we take, for example, hydrogen with mass 1 and deuterium, for example, which has mass 2, look how they differ in terms of physics. For example, the boiling point for hydrogen H2 will be minus 253 degrees Celsius, and for deuterium it will be minus 250 degrees Celsius. But it turns out then they differ in physical, so it will be different. But the physical properties for these chemical substances, so isotopes are very important particles that form elements. All chemical elements have isotopes. They can be stable, unstable. But once again, I remind you that today we have discussed the question of what atoms will turn into when they lose or gain electrons. In this case, this point is also important. Goodbye, see you again.